Hello, I'm back for part two of my lecture. You recall we ended up with sort of halfway in the discussion of the demand for labor and capital. So what we did say was that to maximize profit, the first order conditions are that the partial derivatives of profit function pi with respect to L and with respect to K are both zero. Okay. Now there's also a second order condition to make sure that it is maximum, which is a little complicated, but certainly it says this, the FLL, the second order partial derivative of f with respect to L, and similarly KK, FLL, FKK must be greater than FLK squared. Okay. So we have done this, so I don't want to go back here and waste my time. So I want to go to the next topic, which is important for us, which is that of the two plant competitive firm. Okay. The two plant competitive firm, which is in case C3, it starts in page 2 but immediately jumps to page 3. So as you can see, so maybe I'll show it to you. This is page 3. I don't know if you can see it. Okay, so that's page 3. If you start on page 3, it shows, let me just say this. First, we have a firm which has two plants in two different places. I mentioned this before, but puts the output together and sells it in one market at a given price. Okay, so so what's the profit function in this case? As you see in equation number 1, it's FQ1 Q2 is P times the Q1 plus Q2, which is the total output produced from both plants, times the price minus the cost function. The C is Q1 Q2, where the two plant conditions may be tied together in some fashion. That's why you have what's called a joint cost function, okay, which is C Q1 Q2. So that's equation 1. Now obviously all we are left with now to do is to put the first and second order conditions for maximum, which are that the partial derivative with respect to L is 0, partial derivative with respect to K is 0, that makes FOC. The SOC again is similar to the earlier case where you have the second order partial derivatives are less than 0, and then the cross pi LL, pi KK, in this case of course pi 11, pi 22 minus pi 12 squared greater than 0. That's equation 5. So equation 2 gives us the first order conditions. Equation 3 tells us that the first order conditions in fact mean that P equal to C1 and P equal to C2. That is, the market price is equal to the marginal cost in either plant. Okay, so which implies that P is equal to C1 as well as to C2. That means C1 must be also equal to C2, which means marginal cost in plant 1 must be equal to marginal cost in plant 2 at the optimal output. Why is this? Is also intuitively obvious to you, because if the marginal cost were higher in one plant than in another, the firm could easily switch one unit of production from the higher marginal cost plant to a lower marginal cost plant, thereby increasing the profit, reducing the costs, which means increasing profits, still making the same level of output. It's just that one unit has been produced in plant 2 rather than in plant 1. Okay, so clearly the marginal cost must be equal. All right, that's that. So that's essentially for the two plant system. As you can see, in each case, the main thing is to put the proper profit function. Once you have the profit function, it is simply maximizing a function of two variables, which is not such a big deal, right? So you have to know how to set up the profit function. All right. Now, if you go to, for example, now to the two output case, which is let us see now, it is case C2. Okay, case C2 on page 2. Okay, here it is. I can show it to you once. Okay. You see that? All right. So that's page 2. Now, that's in the bottom half of that page. It says multi-product firm. Now here, let's see what it is. Here is a firm producing two products, right? It may be a single plant. It may be, if the example I gave you was that of a farmer, for example, who raises cattle as well as has a crop, for example, of wheat or something like this, or a clothing product producer who has both men's clothing and women's clothing. Some of the machines may be common, right? So just small changes. So therefore, in this case, we have either it's possible, for example, to have a joint cost function for them or separable cost function, which is a cost function for first commodity and a cost function for second commodity, and then you just have to add the two to get the total cost. So that's what it is here. And it's because these are two separate products, they have their own markets. You cannot say price for one is price for the other one, because they are two different products. You cannot compare the prices, right? So clearly the prices are different. So the amounts are different. So therefore, the revenue from the first product is P1 Q1. Revenue from the second product is P2 Q2 minus the total cost, which could be a joint cost function. In this case here I have a separable cost function, C1 Q1 plus C2 Q2. However, it could be a C Q1 Q2. Okay. If, for example, it's like a farmer doing both cattle and a crop, likely it is a joint cost function, not separable, right? Because the same guy maybe so same supervision, and then some of the things are very common, like the land and so on. Okay, so that's it. So once you have that, clearly now I need first order conditions, which is pi 1 equal to 0 and pi 2 equal to 0 as usual, right? So pi 1 you can see is P1 for the P1 Q1. So we are now differentiating with respect to Q1 only. Okay, so the first part P1 Q1 gives me P1, right? The second part P2 Q2 gives me nothing because it has no Q1 in it, right? So P2 is constant and Q2 has no Q1 in it, obviously. So that is 0. And again C2 Q2 gives me nothing, but C1 Q1 gives me the partial derivative of C1 with respect to Q1, which is nothing but the marginal cost for the first commodity. So the first condition says P1 minus C1 prime Q1 0, and the second one says P2 minus C2 prime Q2 equal to 0. So and then when you solve these two equations for the two commodities Q1 and Q2, the amounts, you get the supply functions, because we are saying how much does he produce given the prices of the first one, the prices of the second one, and the cost functions, how much does he want to produce Q1 and Q2 to maximize his profits. So clearly the solution to 2 here, which is the two first order conditions, gives us the supply curves. For example, Q1 equal to Q1 P1 and Q2 equal to Q2 P2 from this in 3. Now clearly in Q1 equal to Q1 P1, that's the first supply function for first commodity, there is no P2 at all. The price of the other one is not involved. But if we had a joint cost function CQ1 Q2, probably we would have had both P1 and P2 involved in each of the supply equations for each of the commodity. All right, so that's probably what would happen. Clearly the second order conditions are similar to the earlier case, pi 1 1 less than 0, pi 2 2 less than 0, etc. So pi 1 1 less than 0, for example, simply means that this C1 double prime Q1 greater than 0, which simply says the marginal cost of the first commodity must be increasing. Similarly, the marginal cost of the second commodity must also be increasing.
I believe I have run out of time for this segment. So look out for part 3. So I'll be back again with additional material. Okay, take care.